And so we continue on with the first problem of this rapid fire set. I thought this was the point in the test where things took a turn for the difficult. I was at a time at the start of this problem of 16 minutes 34 seconds. And the only one in the first 10 that really caused me to have a setback was number 3. Because I was trying to, the circle thing set me back a little bit of time where I thought it was a circle equation instead of a sphere. And so besides that, I was doing good. This one took some time. It really ate it up. If you were to have skipped one in the first 15, this would have been it. Not that you couldn't do it eventually, but it's a time test and we don't have eventually. So if you ended up skipping this, I commend you for that. If you thought of the solution path really quickly, I commend you for that as well. Let's get to seeing what made it so challenging. It's more like physics, I guess. Emily sees a ship traveling at a constant speed along a straight section of a river. She walks parallel to the riverbank at a uniform rate faster than the ship. Okay, so let's think about this. I don't even know what to write for that. Okay, so the ship's going this way, she's going this way, but she's going faster. Her vector's longer because she's going faster speed. Okay, she counts 210 equal steps walking from the back of the ship to the front. Keep in mind, the ship is moving. So if she goes 210, the boat, let's say the boat goes X, right? She, to get from the back to the front, needs to go the difference, right? More, right? So then she's going to subtract what the boat went in that time. That is the length of the boat. Okay, so if she goes this way and then you take away what the boat did, because that's taking away from her total distance traveled, the difference here will be how long the boat actually was. Okay, that's important. Okay, now, what's next? Walking in the opposite direction. So now she's going this way, boat's going that way. She counts 42 steps of the same size from the front of the ship to the back. And this is kind of weird. I think the best way to think about it is have Emily go first. Just freeze the boat, pause it in time. You've got that clickable remote that they've got in that one movie. And you're just going to freeze time for Emily, or for the boat rather, and Emily's going to walk her 42 steps. Will her 42 steps be enough to cover the length of the boat? Clearly not. The lowest answer over here is 70. So then if you freeze Emily now and have the boat go, because she's gone so far the length of the boat, but think about this. Do you notice anything about 42 maybe in relation to 210? If you do, it'll probably clue you in that you might be on the right path if you consider that. Namely, this is 1/5 of 210. So if she goes 1/5 of her steps, the boat's going to go 1/5 of its distance when it gets to travel the equal amount of time that Emily just traveled. So the boat's going to go x over 5, and because we froze each of them while the other one went, if I sum this distance, when the boat's gone x over 5 and she's gone 42, the boat will now be at the back end. She will be at the back end of the boat. So you actually need to add these, and this too will equal the length of the boat. Okay, so this is kind of weird. Make sure you understand it, right? So the boat, right, it's here. Here's the boat. I'm a great boat drawer, as you can see. Emily's here. She's going to be walking backwards. Is that how you write the E? I'm even confused now. Yeah, it is. It felt weird looking at that way. Okay, so she's going this way. She's going to go 42 steps. The boat's not moving because we froze it in time. She's not quite to the back yet. She's like right here. Now, we're going to freeze Emily in the second position. The boat's going to travel for the same amount of time that Emily just traveled. And since she went 1/5 of her previous steps, the boat will go 1/5 of its previous distance when she traveled 210. And so you can see then by adding them, if she will then be at that time, because they've actually traveled the same amount of time. I just froze one there so we could think about it differently. It's true when you think about it. This sum of their two distances will be the combined sum will be the length of the boat. That's it. That's the secret right there. You can also do a rate times time equals distance approach, but you still have to make this thought before you can get it right. So I'm going to multiply this by 5 to get 210. and multiply this by 5 to get x, the x right here. I'm just going to do that. And then this times 5 as well. So what do we do next? Well, we add the two equations so that the x goes away, and you're going to get 6L equals 420. And we want the length of the boat. What is the length of ship, boat? It's all the same. 420 divided by 6, you're going to get 70. Really, this is really a challenging question. Yeah, so don't feel bad if you had to skip it. Don't feel bad if this is the first one you got wrong. It's a worthy opponent. It really is difficult to think about. To my knowledge, on the AMCs, we've never had kind of this opposite motion kind of thing going. I think I might have seen some stuff like that in Volume 1, and I forget where else. Maybe Algebra 1, the AoPS Algebra 1 book. But if you got it right, good job, and we are on to problem 12. Okay, for this problem, the Fall 2021 AMC 10A problem 12, 12A problem 10, the last one of this rapid fire set. For this problem, you might want to pause the video and go watch a primer on modular arithmetic. There's one on my channel. It's got all caps Modular Arithmetic Intro in the title. It might help you understand better what's going on here. The base 9 representation, wait, do I want modular? Yeah, we do. Base 9 representation of the number n is this ugly looking thing. Don't try to read it. No, that's painful. Just that's it. It's that number. It's all you want to do when you're reading. You're trying to go quick. You're not going to gain any benefit by looking at all this right now, okay? Just notice the 9 and that's about it. What is the remainder when n is divided by 5? Okay, so first, what is this in terms of why is it in base 9? It's so that you can write it like so. 2 times, and it's going to be 9 to the power of, this is 9 to the power of 0 place, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 9 to the power of 10, okay? Plus 7 times 9 to the power of 9, and I'm going to put a line underneath that as well, plus this is 9th power, 8th power, 7th power, 6th power, 6 times 9 to the 6th, plus nothing matters here. This is going to be 9 to the 1st power and 9 to the 0. So you will have 5 times 9 to the 1st plus 2 times 9 to the 0. A great book to get better at this is the Intro to Number Theory book from Art of Problem Solving. And so that's actually where I learned everything about number theory. I haven't learned it from any other source. So let's change this to a time symbol to be consistent. My OCD is going to get upset. So what do we do with this? How are we going to use modular arithmetic to figure out what the remainder is when we divide this by 5? Well, if you don't know what just happened, it's the same thing that happens if you do 471 in base 10. You would write 4 times 100, if you expanded it, plus 7 times 10 plus 1, which is 4 times 10 squared, even though it's in the 3rd position, plus 7 times 10 to the 1st, even though it's in the 2nd position, the power is only 1 on the 10, and then 1 times 10 to the 0. It's just that, you're just swapping out the 10s for a different base of 9, and that's what we did. So now, you might not know this, but if you do 9 is congruent to what in base 5? This is the congruent symbol for modular arithmetic. It would be congruent to 4, and you write mod 5. Not base 5, but mod 5. Sorry, it's the kind of same thing. So 9 is congruent to 4 mod 5, but did you know with mod, you can, with modular arithmetic, modulo 5, those are the proper words, I'm just shortening them, you can go into the negatives. You can actually say this is congruent to -1 mod 5 as well. And the reason for that is this is 5 times 1 plus 4. This is 5 times 0 plus 4. And this is 5 times -1 plus 4. It's the negative first multiple of 5 plus 4. Okay? So then that gives you -1. All of these numbers have the same quote-unquote remainder when you divide them by 5. So why does it matter? Because if I have 9 is congruent to -1 mod 5, if I take this to any power, I do the same to the other side, and it will still be a true statement. Which means this 9 to the 10th Again, I'm not going to be able to explain this in detail in this video. You can watch the other video to get more in-depth explanation of these ideas. It's like 3 chapters of a book. I can't summarize all 3 chapters in a short video. I did the best I could on the other one, the Modular Arithmetic Intro one. Maybe I'll link it in the description if I have time at some point. But if I take 9 to the 10th power, then -1 will go to the 10th power. And this, we call it modding out. We can mod it out to be 1. And I will have 2 times 1, which is what this expression will become, plus 7 times it'll be -1 because you have an odd power. So you're going to get -7 and then plus +6 because that's just going to mod out to 1. This is going to mod out to -1. This is going to mod out to 2. It's already modded out basically because the 9 to the 0 doesn't really matter. So what do we have now? We've got 2 plus 6 is 8 plus 2 is 10. And I do 10 and then I subtract the 7 and the 5, which is 12. I get -2. Now just like I can start at the -1 and add 5 to get back to a positive number, so I can do the same with -2. If I take -2 and add the modulo back to it, I will get the answer they are looking for. It's going to be answer choice D, which is 3. And again, this is 5 times -1, the negative first multiple of 5, plus the remainder of 3. Okay, so that's it for now. Again, I'm sorry if it wasn't fully as clear as I usually do, but I've got to film a lot today. Watch the other one for a primer on it. It'll make more sense for those of you who didn't understand what I did. For the rest of us, we're going to move on to the next set for the 12 and problem 13 for the 10A. Let's get going. And here we go, on to the 2021 AMC 10A fall version, problem 13. Each of 6 balls is randomly and independently painted either black or white with equal probability. There's no greater chance for one or the other. What is the probability that every ball, that's all 6, has the property basically is that it is different in color from more than half of the other 5 balls? This one didn't seem too challenging to me. The first thing I did was say, well, let's start right in the middle. Let's see if it's even possible. I mean, it has to be because there's no 0 answer. But if I was to take, let's say, a black one, right? Then that black one would be different in color from more than half. So what is it different in color from? The 3 white, right? So the 3 white, it's different in color from 3 out of the other 5. Okay. And if I had chosen the white, it would just be a reflection, right? It'd be different in color from the 3 black out of the remaining 5. So this definitely works if I had 3 and 3. Okay, then what about if I had 2 and 4? Let's say I had 4 black and 2 white. Would it still be true? Well, it would be true from this perspective, I think. If you chose this white one, it would be different in color from 4 out of the remaining 5, which is more than half. Different in color from, this is important, more than half of the other 5. So 4 plus 1 is different from 4. That's more than half. But what if we switched it to the B instead? Because it says that every ball, including the black ones, have to have this property. So now this black one is only different in color from these 2. And 2 out of 5 is not more than a half. So your goal then is to figure out the probability of something like this. And you know what this is going to end up being? It's exactly like the topic I talked about recently in Don't Memorize, Understand, that video. I'll maybe link that in the description if I have time, if I can remember to do so. How does it work? There's 2 outcomes, and I need to have 6 choose 3 successes. Again, the formula is n trials with k successes. The probability of success to the k power 1 minus the probability of success, which is the probability of failure, to the n minus k power. This is the probability of that event having k successes. And I just want 3 successes. Doesn't matter which way you think of it, the blacks or the whites could be successes. And so you're going to have, but what's the chance of making one of the balls be painted black? or white. They're both 1/2. So it's really 6 choose 3 times 1/2 to the third times, that's the chance you want 3 successes. That's the number of successes. Chance of success is 1/2. Chance of failure is also 1/2. And you want 3 failures, quote unquote, as well. So then, what does that give us? 6 choose 3 is 6 times 5 times 4 over 3 factorial. Technically, there's another 3 factorial and another 3 factorial. When I'm doing my test, I'm not writing that because I'm going to cancel it. The formula, again, is 6 factorial over 2. It's this as a factorial over the difference as a factorial over with the bottom number also as a factorial. This should be a well-known concept going into the test. Guaranteed every year, at least on either the A or the B, you will probably have to do combinations once. Make sure you get some practice at it. So then 3 factorial is 6. This cancels. It gives you 20. You're going to have 20 times 1/2 to the 6th power, which is 1 over 64. So it's 20 over 64. 4 goes into this 5 times. 4 goes into this 16 times. Answer choice D again, 5 over 16. Let's do 14. All right, so here we continue on. This is the 2021 AMC 10A from the fall version, problem 14. How many ordered pairs XY of real numbers satisfy the following system of equations? First, if you didn't know one key fact, this probably took a little bit longer or was not solvable for you. Main thing is, how do you deal with absolute value? There's 2 approaches that we could have taken with this problem, all right? Typically for absolute value, number 1, it's squared as well. Ugh, what's going on? I don't even know. It's not fun, right? Not fun, it feels like. Well, before we get to actually how you will handle these, let's just get rid of the squared by square rooting both sides. And when you square root the both sides, you're going to get plus or minus 1. The reason for that is when you square root something, you get, like that's squared, you get the absolute value of that thing. But if the absolute value of that thing is equal to 1, when you peel off the absolute value, it's actually 1 or negative 1. So let's do that first. We're going to get this bottom one square rooted. I'm going to have absolute value of x plus absolute value of y minus 4 is equal to 1, or the absolute value of y plus the plus the absolute value of y minus 4 equals negative 1. Okay, so we've got this equation and either of these being true. And we're looking for ordered pairs that are solutions, essentially. So what could we do next? Well, I'm going to move this negative 4 over, right? When you're doing complicated problem solving and you're like, man, I don't know what I'm going to do with this part, then don't think about that part just yet. Take care of everything else that you know how to move minus 4 across an equal sign. And sometimes when you're looking at the next part, it will start to make sense. So absolute value of x plus absolute value of y equals 5, or absolute value of x plus absolute value of y equals 3. So then we've got this equation and these 2 equations. Now what? Now we got to get down to figuring out what you do with this. If you have seen, there's been similar problems before. I think even in the last 2 years, there's been one just like this. And what I've got written in my small notebook, because this is kind of weird. Where do you learn this equation? Well, for most people, you probably don't. I've seen it in challenge problems in Algebra 2 textbooks sometimes, for some books, but not all. Most teachers aren't even going to cover that content. And so you either find it somewhere through math competition websites or you don't. And so if you don't, you're going to have to use your wits to get past this problem. I would easily, if you've never seen this before, I would easily add 2 minutes to 3 minutes to your solve time if you get it at all. And that's fine. If you were able to overcome having never seen this, that is an incredible accomplishment, for real. So what I have written is this. It's A absolute value of x plus B absolute value of y equals C. And I just wrote above it, it's a diamond graph. That's what the graph looks like. Now that's not true if this is a minus sign. Okay, so how does it work? Well, I know what the diamond thing looks like. Basically, if I graph this, let's say x is 5. What could y be? Only 0. And you can put 5 here and we'll go, and if y is 5, x would be 0, and if x is negative 5, y would be 0, and if y is negative 5, then x is 0, because absolute value of negative 5 is 5. X has no choice but to be 0. And what's really going to happen is it's going to connect like this. And if you knew what I did, it probably doesn't look too diamond-like. If you knew this, man, the problem kind of falls apart pretty quick. But if you didn't, how would you come up with this if you didn't know? I want to explore that right now for those of you that had to go that route. What I do is just think about the definition of absolute value. That is equal to a piecewise function. It's x if x is greater than or equal to 0, and negative x if x is less than 0. So if I know that and I'm trying to use a graphing approach, which maybe you didn't even try that, if you're trying to use a graphing approach, think about the quadrant. In the first quadrant, both x and y are positive. So you could do, and I actually did this on part of my paper just to look at it. In quadrant 1, technically it's quadrant 1 like this, but whatever. In quadrant 1, I can just take off the absolute value. It would just be this or this. Either one of those would be fine. What would it look like then? It would say x plus y equals 5. If I was to graph that line, well, just move the x over. It's y equals negative x plus 5, which would mean it has a y-intercept of 5 and a slope of negative 1, which means you would go down 5 and over 5. You're going to hit that point right there, and that's what it looks like in the first quadrant, just for this piece. There's still another piece over there as well. Now, what if you put it in the second quadrant? In the second quadrant, is x negative? It sure is, and since it's negative, that's less than 0, you would write negative x. But wait, I thought absolute value, how can it be negative x? I thought it had to come out positive. It does. Let's let x equal negative 3. Plug that right here. What's negative 3? It's positive. Don't interpret a negative in front of a variable as a negative value. Okay? So then that would make it positive, which is why when you peeled off the absolute value for this, for the second quadrant, quadrant 2, you would have written negative x plus y equals 5. But why is y positive? Because in the second quadrant, the y values are positive. These are actually important things to think about. So move the negative x over, you're going to get y equals x plus 5, which again has a y-intercept of 5 and a slope of 1, and it's coming down here, and it will hit right there. And that should be enough to convince you of what's going to happen as you go around the outside. So what about the other one? It's going to be the same thing, but at 3. 3, 3, negative 3, negative 3, another diamond graph. And it should look something like that. All we have to do now is graph this expression here, which kind of got crowded with my other explanation. So I'm going to move the x squared over and divide by 3. Y equals negative 1/3 x squared plus 3. Again, I just did it all together in one shot, which is not highly recommended, but we're saving time right now. Moving x squared over and dividing by 3, it becomes negative, and you get negative 1/3. The 9 divided by the 3 gives you 3. Be very careful doing 2 or 3 steps in your head at once. That is usually how mistakes happen. I'm taking the risk because I've already done this problem earlier, and I know that this is what it looked like. Okay, so what now? Graph this. It's got a, how do you graph a quadratic? Come on, negative b over 2a is the x value of the vertex, and we don't have a b value, which means it's 0, and then if you plug in 0 for x, what I'm doing is negative b over 2a equals 0 because b is 0. Then you plug the x value of the vertex in and you're going to get 3, but really you should know how to do a little bit of graph shifting. This is the parabola at the origin shifted up 3. So where's that going to be? Right here. That's where it's going to start. Well, we know it's going down. Is it going to come in here and maybe hit 4 more points? Or where's it? How many more points will it hit? It's going to actually have to come out this way, right? So what if it hits 1, 2, 3? It's kind of hard to tell what's going to happen, right? So let's see. What could we do? Well, why don't we just plug in the y value of 0? Because that's the value on the x-axis. If I make this 0, okay, on the parabola, then I could move the negative 1/3 over here. It becomes positive. You would have 1/3 x squared equals 3. You would multiply by 3. You would square root and get 3 and negative 3, which are the values right here. And you know it's going to go like this. Okay? and come down. Now, you might feel confident right now. There's 3 points of intersection here and 2 more here. You might be confident the answer is 5. But what I would advocate is just to always be asking yourself, but wait, what about if this parabola actually eclipsed and hit the side of the outer diamond? Well, if that happened, you would maybe get other solutions. And then it could, like, for example, let's say it went like this and then came down here like that. It's not very likely, but I'd probably check it because it doesn't take long to do. In fact, we have this equation right here. It's x plus y equals 5. All I would need to do, or y equals negative x plus 5 as well, plug this in to this equation and see if you get any solutions. So if I let y equal negative x plus 5, I'm going to go up here so I have space. Negative x plus 5 would then equal negative 1/3 x squared plus 3. If this has solutions, meaning if this comes over and hits this bar right here, then this will have a solution. It'll have an x value where that happens. Let's see if it does. If I move the 1/3 x squared over, I have positive 1/3 x squared minus x, move the 3 over to get plus 2 equals 0. Now, how do you know if a quadratic has solutions? The inside of the quadratic formula, right? The discriminant, it's called b squared minus 4ac. If that is less than 0, there's no solutions. Let's see if it is. B is the negative 1 right here. If I square it, I get 1. Minus 4, my A is 1/3. My C is 2. Well, 8/3 is bigger than 1. That's negative. There's no solutions. It definitely does not do that. But now we're not thinking it doesn't. We know. And that way, when you go to problem 15, you're not still thinking about 14 and it's clouding your thinking on that problem. That can pay dividends on the later problems in the test by a lot. We get 1, 2, 3, 4, 5. You might think, well, don't they all 3 have to intersect? No, because the 2 diamonds together are this equation. Together they're this equation. So because of that, if it hits either one, it's a solution to the whole thing. In fact, you could just take a point and plug it in. 3, 0. Let's see, if I plug in 3, all these ways to check your work, right? 3 plus 0, you know, your absolute value, you've got 3 minus 4 is negative 1, square it to get 1. Works here. Let's check here. 3 for x is 9 plus 0, 9. It checks out. There's so many ways you can check your work as you go. And if you're worried about, you get a lot of things wrong usually, 4 or 5 sillies per test, that's how you prevent them. That's one of the ways. There's other ways too. I still want to make a sillies video in the future. But for now, it's getting kind of silly late, and I got to get going on more filming. We're going to get to problem 15. And we continue on with the fall 2021 AMC 10A problem 15. This one also took me a little bit of time, but it shouldn't have. There were observations I could have made earlier that would have saved me significant time. At the end of this problem, I was at 43 minutes and 26 seconds. And so if you compare that to where I was at after problem 10, which was 16 minutes, 34 seconds, I took about 27 minutes on the 5 problems from 11 to 15. That's a long time. I probably should have skipped 11, maybe this one if I didn't get it faster. Yeah, even I need to learn about time management. We got to learn to skip when we're not ready. Might have had more time to get other questions later in the test. But I'm going to explain it now with what I realized later into the solution process. So isosceles triangle ABC has AB equal to AC equal to 3 root 6. So I don't know what this looks like. I'm just going to draw it like this, right? You're going to have A at the middle because that's the letter common to both. I'm going to have B and C here, and we're going to connect. Now my first thought about isosceles triangles is that if you drop the altitude, it's perpendicular to the base and it makes 2 congruent triangles. Keep that in mind. Next, a circle with radius 5 root 2, okay, is tangent to line AB, not segment, line. So you're going to have to go extend out and have a circle tangent at B and line AC at C. So we got to extend out this way too. Let me draw this a little bit straighter, maybe over here. I draw it, look at it straight on so I can draw it more accurately. It's hard when you're writing from an angle to be accurate. Okay, so wait a minute though. with radius 5 root 2, which is bigger, 5 root 2 or 3 root 6? Let's do a quick check. 5 root 2, 3 root 6, square both of these to compare. You'll get 50 compared to 9 times 6 is 54. That's bigger, which means the circle's not going to hit A. And you need to know that. So then we go over here. Let me just try and draw it straight on so that we can make it slightly more accurate. Maybe like this. Okay, something kind of like that. Guess I'll use the eraser and go a little bit faster here. Okay, so this is the circle here. Its radius is 5 root 2. Where's the center of it? Well, let's place it right here. There will be the center. And since it's tangent at B, what are we even doing? Let's continue reading. Okay, what is the area of the circle that passes through vertices A, B, and C? At one point in the problem, one thing that went through my mind was ABC over 4 times the circumradius is the area of the triangle. So if I was able to find the length of BC, I thought about doing that, the A, B, and C being the side lengths. I would also need to know, why is it circumradius? Because the circle that goes through those vertices is the circumscribed circle. There might be a way to do it this way, but I abandoned that path at some point because I thought about the other circle here and something interesting about it. Number one, this is a common knowledge. Everybody's supposed to know this. When you connect the center of a circle to the point of tangency, it makes 90 degrees. And if you come over here and connect it to that point of tangency, it will also make 90 degrees, which means those are 90. Furthermore, that's a radius. And that means this is isosceles with the exact same segment as the other triangle, meaning if I drop this straight down, it will be perpendicular to the other diagonal because I can only hit one midpoint of BC, and this one has to hit the midpoint, and this one has to hit the midpoint. If I call this circle O, for instance, okay, then what? OB is going to be 5 root 2, and this is 5 root 2 as well. And this is actually where you want to be able to see what's going on. Think about this quadrilateral ABCD, or ABCO. Maybe I should call it D or something instead. Let's do that. It doesn't really matter. ABCO. All right. You know something about it? It's cyclical. And do you know why it's cyclical? Because the opposite angles add up to 180. And so if it was cyclical, that means that all 4 of these points are part of a circle. But there's only one circumscribed circle for any given triangle. There's not 2, which means if there's a circle that goes through O, A, B, and C, that circle is the circle that they're talking about right here. And that would mean that because this is 90 degrees, if you have a circle and there's a triangle inscribed in it that makes 90 degrees, the hypotenuse of that triangle is a diameter of the circle, which means the circle they want the area of a circle that passes through here. If I can find AO, then I can find the diameter, cut it in half. That's the radius. Pi r squared will be our answer. This is it. I didn't think about that fact until I had chased a couple rabbit holes, didn't produce fruit, went back to the drawing board. I think at some point I put this 90 here. I even tried to go, because I knew this was 90, I tried to go here and use that similar triangles technique. None of it's needed. It's right there. AO is the diameter of the circle we want. They're the same circle. Realizing OABC is cyclic, which means a circle can go through all 4 vertices. That is the break in the problem. Once you had that, let's find AO, because I've got 3 root 6 and 5 root 2. It's just Pythagorean. In fact, we've already squared both of those. We squared them here, 50 and 54. If I add those squares and square root, that is AO. Furthermore, you can tell that 4 goes in. It goes in 26 times. And when you pull the 4 outside, it becomes a 2 root 26. That is AO. Half of that is the radius. The radius root 26, pi r squared. We get C. And we are on to the next question. For me, at this amount of time, if you're curious, I was able to answer 21 questions under the timed conditions. Maybe I could have got more if I didn't get bogged down on some of these problems longer than I would have liked. So let's get on to number 16.